All right. So we are doing the living answer key to energy calculations involving phase change practice number 1. The first few of these were done in lecture, so we want to make sure you're looking at the same worksheet here, and I'm going to pick up here on number 3. At any point in time in this, if you would like to pause and try the problem yourself and then catch up and see how we did it, or if you have done these and you want to fast forward to something else, please feel free. But this is just me going through how to do all of the problems on, again, phase change or any energy calculations involving phase change practice worksheet number 1. All right, so if we're looking at this question here, it says, please calculate the heat released, and it doesn't matter if we're gaining or losing energy, we're going to keep everything positive here, when 653 grams of steam at 100, that would put us right here on our scale. Remember, this is a solid that melts to a liquid that boils into a gas, and we can come back down. Gas will condense to a liquid, will freeze into a solid. Some very important temperatures that we have here would be 0 for our melting and freezing, and then 100 for our condensing and our vaporization. So we are asked for our steam at 100 degrees Celsius right here to condense and then cool to water at 90 degrees. So we're going to go here and stop about there at 90 degrees Celsius. Okay. So first, I like to write out my words as to what I'm going to do. So first thing, it says you're going to condense. The first thing we have to do is a phase change. 1, you're going to condense. And then number 2, you're going to cool. And I think it's always helpful to write what state you're in. Remember, if we're condensing, that means we're going into a liquid. You're going to cool your liquid to 90 degrees Celsius. All right, so that means once we hit 90, we're where we need to be. So that means we have 2 Qs, Q1 and Q2. Q1, I am doing a state change. So if you look here up at the top, if we are doing a state change, that means we are doing Q is equal to M delta H. We have fusion, that is melting and freezing, and vaporization, that is boiling and condensing. If you have a temperature change, you're using Q is equal to MC delta T, and it depends on what state you're in, but these are your C values for your different states of matter. Remember, there is no delta T in a phase change. That's why we do not use this. We use Q equals M delta H. So my first thing I'm going to do here, it says that I would like to condense. So I'm going to do Q is equal to M delta H. And the delta H that I'm going to choose for this one, condensing, is going to be the vaporization. I'm turning it from a gas into a liquid. So I'm going to take my mass, which is 653 grams. I'm going to multiply it by 2260, which is my delta H, or how many grams or how many joules it takes to condense each gram. So when we multiply these together, I'm going to get 1475780 joules. Q2, it says I'm going to cool to water. If I'm cooling, that means I'm going to use Q is equal to MC delta T. Right in our wheelhouse now. M is 653. Okay. Times, we are in the liquid phase, so we should know that our C is 4.18. Times, now this can be kind of tricky. Some students will say, hey, it's cooling 90 degrees, and plug that in there. However, if you take a look, when you condensed it, it was at 100 degrees. So to go from 100 to 90 is only a delta T of 10 degrees. So we're going to put a 10 here. And when I multiply that together, I get 27295.4. Now, if you can think of these, joules. If you think of these as tolls, all you have to do is add these together to figure out the total amount of energy it took. And that, coming off your calculator, should be 1503075.4 joules. Again, a very large number here Whoops, that's not right. A very large number here of joules to make that condense, okay, and then cool to 90 degrees. All right, here we go. Big one here. How much energy is needed to change 100 grams of ice at -40 to steam at 120? So I am all the way down here, ice at -40, and I want to be steam at 120 degrees Celsius. Remember, we have two things. Q is equal to mc delta T if I am in a state and changing temperature, and I have Q is equal to m delta H, which are the given numbers if we are melting or freezing or we're on a flat line or condensing or vaporizing. If we were to write in words what we want to do first, the first thing, you said I'm ice at -40 degrees Celsius, way down here. I cannot melt if at -40, so I must warm my solid to 0. Good. Now, I have warmed here, and I am a solid at 0 degrees Celsius. Now, I'm not a liquid, so I need to go through that phase change, stop and pay that toll, and I need to melt. Now I'm over here, and I'm a liquid at 0 degrees Celsius. So then I need to, before I can boil, I need to warm all the way up to 100 degrees. So I'm going to warm my liquid. Good. I'm not steam yet, though. I would like to be steam, but I have to make sure that I boil first. Have to go through that state change. So I'm going to boil. And then number 5, I don't want to just be, this is gas at 100. I would like to be a gas at 120. So I'm going to warm gas to 120 degrees is my final temperature. Okay, just a side note, you will not have this graph on the quiz, but you feel free to draw it if you would like. But let's quantify everything we're doing here. All right, so we need Q1. I'm going to run out of room here. Q2, Q3, Q4, and Q5. All right. So the first one, warming. That means I'm going to do Q is equal to mc delta T here. So I'm going to take my mass, which is 100 grams, and I'm going to multiply it against my mc. We are a solid. Look at the top of your paper. We're going to use the solid, which is 2.06. I guess we should slide up and take a look at that. We got that number from right here. That's the C for a solid. Wonderful. And then how many degrees are we going? Well, we're trying to get to 0, and we're way down here at -40. So to go -40 all the way up to 0 is a delta T of 40. Okay? And you can always pause this program and multiply those together. I'm running out of room here. So let's do number 2. So you would multiply those together and get an answer. Then we're going to melt. Melting is a state change. There's no temperature change here. So I'm going to do Q is equal to m delta H. So I have 100 for my m, or my mass. I'm going to multiply that against 334, which is the amount of energy, the delta H, that it takes to melt and to freeze. Okay, so we got that number. Beautiful. You would multiply that together. Then next, Q3. We're going to warm our liquid to 100. So again, I'm warming. So I'm doing my Q is equal to mc delta T. So I'm going to do 100, okay, times 4.18. That's our lovely number we've already memorized. And then now I'm going to go 100 degrees because I already warmed to 100 or 0. And then to go to 100, the delta T would just be another 100 degrees. So I want to go from here up to 100 degrees. So times 100. And you would multiply those and get another number. Awesome. Now, I'd like to boil. Go in here, this phase right here. Again, if we are flatlining, that means we're doing Q is equal to m delta H. If you are boiling or condensing, we're using the 2260 for our vaporization delta H. So I'm going to go 100 times 2260. Getting myself there, and you'll get another number. And then Q5, this is where the last little bit gets tricky. I would like to warm my gas to 120. So I'm going to do Q is equal to MC delta T one more time here. So I'm going to go 100 times, and your C value for gas is 2.02. You can find that on the top of your paper. Now, a lot of people might say, oh, let's put 120 in there, okay, which is not our delta T left. We have already paid to heat it to 0, to melt it, to heat it to 100, and to boil it. We are all the way up here. You have already paid to heat it to 100. So all we have to do is go 20 more degrees. So this delta T is 20. When you add those all up, you should get a final answer of 31348.0 joules. So again, you're multiplying across and you're adding. If you have any questions, come and see me. I just ran out of a little bit of room here. 313,480 with a decimal. Okay, awesome, good. So let's flip the paper over and let's try to do some of the problems on the back. Number 5. How many joules are given off when 65 grams of water are cooled from 25 degrees Celsius to negative 25 degrees Celsius? So what we're looking at here is that we are at 25 degrees Celsius, and we would like to be negative 25 degrees Celsius. Now, we know that we cannot just change 50 degrees. I guess that both looks like negative. We cannot change 50 degrees because, first of all, we cannot have a solid that is above 0, and we cannot have a liquid that is below 0. So we do have to stop and talk about this melting thing. So if you kind of can think in your head, if you would like to think how many Q's, we have a Q, and a Q, or we can think about them in words, and let's figure this out. All right, so the first thing we need to do, we are water at 25. We cannot freeze at 25, so we want to cool liquid to 0 degrees Celsius. Then number 2, so that got me down to here. I'm 0 here, but I'm still a liquid. So I need to go through the process of becoming a solid. So I need to freeze. Now I'm a solid at 0. I'm a solid at 0, but I am not solid at negative 25, which is what I want to be. So I need to cool my solid to negative 25 degrees Celsius. All right, so let's see if we can't run these into 3 Qs. Q1, Q2, Q3. I suggest at this point, if you have just been going along, I suggest you try to pause the program and do these Qs by yourself. Can you make this happen? All right, hopefully you got it right. So what we're going to do here, our Q1, we are cooling, so that means we're over here. So I'm going to do my M, which is 65, sorry for that glitch. I don't know, smart interactive whiteboard connected. All right, 65 times C, and we are a liquid, so that's our good old 4.18. And then how many degrees? We're at 25 and we're trying to get to 0, so we're going to go 25 degrees. When you multiply those, you get 6792.5 joules. Then Q2, we are freezing. That means there's no temperature change, and that means where Q is equal to M delta H. So my M is 65. If I am freezing, that means I'm going to use the fusion delta H. So I'm going to multiply that by 334, and we're going to get 21710 joules. And then last but not least, I want to cool. So I have already, let's draw where we traveled here. We cooled down, we froze, now we're here, and we need to cool down to negative 25 degrees. So I'm going to go 65. If I'm cooling, I'm doing MCAT. So I'm in a solid, so I'm going to use 2.06. And then I'm going to multiply that. I'm going from 0 to negative 25. We can keep that positive number because it's just a change. So that number would be 3347.5. When you add those numbers up, hopefully your calculator spits out a final answer of 31850 joules. Okay, and the key is below this, we have the key posted. Okay. All right, we got another really long one here. I suggest pausing this program and seeing if you can do this by yourself and then coming back and seeing how you're doing. We only have 3 more, so I'd like to see you trying to do this on your own. All right, welcome back. So what we're going to do is we're going to change our negative 85-degree ice cube or solid, and we're going to change that into steam that's 185 degrees Celsius. So I'm going to have my first cue. I cannot melt. Yep, I cannot melt at negative 85. So first thing I got to do is I have to warm my solid to 0. Then I'm ready to melt. Okay, melting is my next step. 3. I'm going to, now I'm a liquid, I'm going to warm my liquid to 100 degrees so that I can boil. And then number 5, I'm going to warm my steam. I might want to write gas. Warm my gas to final number of 185 degrees Celsius. All right, so that means we're going to have 5 Qs. Q1, Q2, Q3, Q4, and Q5. Okay? So what I would like to do is I'd like to have you pause the program here and see if you cannot figure out our Qs, and then continue going here once you get that started. All right, welcome back. All right, sorry for the interruption there. All right, so we now can come back with, we are warming our 75-gram ice cube up. That means we're doing Q is equal to MC delta T. So we're going to do 75 times our C for a solid times, we're going up 85 degrees because we're going from negative 85 to 0. When you multiply those together, you get 13132.5. Separate from there. Then we're going to stop and pay to melt. We have a 75-gram ice cube that we are going to pay 334 joules per gram to melt. So we're going to go 25050. I'm not putting joules on there. We'll put it on the final answer. Next, I have a 75-gram ice cube. Now I get this liquid water that is already melted. Now I want to make it go to 100, so we're going to use our good old 4.18. And we're going to go up 100 degrees. So that's going to give me that's going to give me 31350 joules. Then I'm going to take it, and I'm going to take my 75-gram ice cube, and I'm going to boil, or I guess now it's liquid water, 75 times the heat of vaporization, which is 22660, which then will give me my 169,500. Last but not least, I am now a gas because I've boiled. I'm now a gas, and I want my gas to go to 185, so I'm going to take my 75 grams of water there, and I'm going to multiply the C for a gas, which is 2.02, and then now, very careful, we already paid to go to 100, I just need to go up 85 more degrees, and I'm going to be at 12877.5. If you add those all together, you should be looking at a grand total of 251,910 joules. 25, that should be a 251,910 joules. Okay. Wonderful. All right. I would have you pause the program again and try to see if you can calculate the heat needed to change a 652 grams of water at 30 degrees, and I'm going to heat that up to steam at 110 degrees. See if you can pause the program and take care of that one. All right. hopefully you got your 3 steps. This is a 3Q. I am water at 30 degrees, so I need to warm my water. We're going to say liquid, warm my liquid water up to 100 degrees. So we can go through the state change and we're going to boil. Once we boil, then we are going to heat that gas all the way up to the remaining 110 degrees Celsius. If you did not get that part, you might want to pause the program now to get your cues. All right, let's quantify this, shall we? If I'm warming a liquid, that means I'm using Q is equal to MC delta T. So I'm going to take 652 times I'm a liquid, 4.18. And if I go to 100 degrees from 30 degrees to 100 degrees, that is a delta T of 70. When you multiply that together, you get 190,775.2. Now, I am 100 degrees, so I can stop and boil. Take your mass, 652, times what it costs to boil, again, that larger delta H, 2260, and you're going to get 1473520. Really big number there. Well, it takes a lot of energy to change a liquid to a gas. And then my last cue here, I am now heating again. I am warming again. So I'm going to do Q is equal to MC delta T, 652 times. We are in the gas phase, so we're going to use 2.02 as our C. And very careful, we already paid to get to 100, so the only change we need to do now is 10 more degrees. When you get that, you're looking at 13170.4. When you add these all up, your final answer should be 1677465.6. Put a joules on that bad boy, and you are good to go. All right, the last one meant to be a little bit tricky, so why don't you pause the program now and see if you can't figure out number 8. All right, number 8, a little bit challenging here. So I'm gonna kind of show you, if this was my quiz, I would remind myself that we start off as a solid, and then we melt, or we freeze, and then we go up as a liquid, and then we boil, or condense, and then we go up as a gas. Okay, and again, at this angle, we are changing temperature while we're in a state, and here we're changing state, so we're not changing temperature. So, in your head, because this one's a little bit challenging, calculate the heat released when 875 grams of water at 100 degrees changes to water at 0 degrees. So, hopefully you figured out by now, there is just one cue. You are liquid water at 100 degrees Celsius, and all they want you to do is cool down to liquid water at 0 degrees Celsius. Okay? Some of the harder things here is if it says, hey, I want water at -50, you need to know that -50 is a solid. If it says, hey, I want water at 150, you need to know that that is a gas. All right, so all we're doing here is we're cooling our liquid to 0 degrees Celsius. So let's knock out that one Q here. Q is equal, if we're cooling, we're going to do Q is equal to MC delta T. Our M here is 875. My C, we are in the liquid phase, is going to be 4.18. And my delta, I want to go to 0. I am at 100. It's just going to be 100 degrees Celsius, and I'm trying to cool down. If you multiply this across, you're going to get 365,750 joules. Okay? Hopefully that helped you. Bring in any questions you have to me tomorrow.